Hi my dear students, in the previous videos we discussed what is meant by reflexive relation, what is meant by symmetric relation and what is meant by transitive relation. That all we discussed in the previous videos, and based on that the 1 mark questions how will be appear in your annual examinations, that also I discussed. In today's class my dear students, let's discuss the questions based on, here it is, based on reflexive, symmetric, transitive, but how the weightage for these questions is 3 marks my dear students. So again today's class, before beginning to this question, just I'll recall the things. What is mean by relation, what is mean by reflexive relation, what is mean by transitive relation, what is mean by symmetric relation, that I am going to discuss. Clear? So my dear students, any relation R, a relation R on a set A is said to be, on a set A R, any relation R on a set A is said to be, first one, reflexive. So it is reflexive if, my dear students, if A comma A belongs to R for every A belongs to the set A. It means, my dear students, you are defining the relation, here it is, you are defining the relation R on a set A is said to be, it means the relation R is said to be reflexive if every element of this set A, my dear students. That's why I wrote here it is for all. This symbol is, it represents for all A belongs to A. Every element of A should relate it to itself. Then we can call the such a relation, we can call it as reflexive relation, my dear students. And next, second one, my dear students, what is mean by symmetric? So what is symmetric relation then, my dear students? A relation R on a set A is said to be symmetric, here it is, if A comma B belongs to R. If any ordered pair is there in the relation R, then whether this implies, if A comma B belongs to R, this must implies that if you interchange the, here it is, elements of the ordered pair, A comma B there means B comma A must be there in the relation R. If any order pair is there in the relation R, then the reverse of this, it means if you interchange the elements of the ordered pair, that after changing the ordered pair, whatever you will get the ordered pair, that ordered pair also there in the relation R. If so, then such a relation we can call it as symmetric relation. And here also A comma B, my dear students, that should be contained in the set A. And next, my dear students, third one is, here it is, transitive. So what is transitive, my dear students? So transitive means if A comma B belongs to in the relation R, if A comma B is in the relation R and B comma C belongs to R, then if two ordered pairs are there, A comma B and B comma C, whatever here it is second, in this order pair, whatever second element is there, the same element should be contained in the, if the same element is contained in the any other ordered pairs. That's why I wrote here it is A comma B and it is B comma C. So if this, here it is second element and here it is first element, if same means, then in that case, if two ordered pairs are there in the form A comma B and B comma C, if these two ordered pairs are there in the relation R, in that case you should check whether A comma C is there or not. If you check, here it is A comma C is there or not, you should check. If A comma C is also there in the relation, then such a relation we can call it as transitive relation. My dear students, please keep in mind, if A comma B is there, B comma C is there, then only we should think whether A comma C is there or not, we should think. If A comma B is not, if only A comma B is there, if there is no B comma C, means we should not discuss, we should not think about A comma C. If a comma c, a comma b comma c is there means then only we should check whether a comma c is there or not. That we should check, my dear students. So this is all about, my dear students, reflexive, symmetric and transitive. And a relation R on a set A is said to be reflexive if a relation R is reflexive, symmetric, transitive. If these three conditions satisfies, means such a relation we can call it as here it is equivalence relation, my dear students. So this all we discussed in the previous videos. Still here it is, just I revised the here, my dear students. And now we'll move to the question, my dear students. So already I wrote on the board, the question is already I wrote on the board, my dear students. So what is the question here it is? The question here it is, determine whether the relation R in the set A, here it is, A is they given to you. Please remember, we are defining the relation on a set A. It means we should know what is set A, my dear students. Please keep in your mind, we should take a one set, or we require the one family. In that family, how the relation is taking place, that we should know. First we should know what is the set A. So what is the set A, my dear students? 1, 2, 3 up to so on. These three dots represents here it is up to so on elements are there. So up to where elements are there? Up to 14 elements are there. It means the set A contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Up to 14 elements are there. So this is your set. In that set, they are representing or they are defining a relation in such a way that, what is the relation R, my dear students? It is collection of all ordered pairs x comma y such that 3x minus y is equals to 0. My dear students, please remember, we are defining the relation. We should find out the relation in which, what is the relation, my dear students? We should, in the relation R, the ordered pair whatever you are taking, that should be from the set A, and they should satisfy this condition. What is the condition? 3x minus y is equals to 0. So what are the elements satisfies this condition, this equation means, my dear students, to find out that, what I'll do, I'll substitute x value 1, x value 2, like so on. I'll substitute the values, and keep in your mind, both x and y value must be from the set A itself. We should not take the elements from the outside. Whatever your x and y values comes, though both values must be from the set A, my dear students. So first of all, what I'll do, I'll solve this equation, my dear students. I'll solve this equation means we should find out the x and y value. What is x and y value, my dear students? X and y value means after substituting the x and y value, equation should satisfy. Such a ordered pair you should consider in the relation R. Then what are those ordered pairs? What are those ordered pair means, after substituting here it is the whatever here it is x and y value, if LHS is equals to RHS means such a ordered pairs we should find out. For that reason, my dear students, what I'll do, I'll put the first x value 1, I'll take, my dear students. So let us take this equation. So before that, my dear students, what I'll do, here it is, let A is equals to, so I'll write first elements 1, 2, 3 up to so on 14. And next, my dear students, relation. How they define the relation? Relation, it is collection of all elements such that 3x minus y equals to 0. This is the relation they define. So I should consider the elements of this relation R. To consider the elements of the relation R, I'll solve this equation. So my dear students, first I'll take the x value as 1, because I am taking x value 1 because I should take here it is from the set A. The starting element in the set A is 1. So let us take here it is, or else put x equals to 1 in the equation 3x minus y equals to 0. My dear students, in this equation what I'll do, I'll substitute x value 1. If you substitute x value 1, 3 into 1 minus y is equals to 0. 3 into 1 is 3 minus y equals to 0, and 3 is equals to minus y. If I shift that side means that is your plus y, that will become plus y. It means, my dear students, first you are giving the x value 1. After giving x value 1, you are getting y value is 3. It means please cross check, my dear students. If you substitute this 1 comma 3 in this equation, means this will become 0. For example, 3 into 1, x value 1 minus y value, you got 3 is equals to 0. Here it is. In this equation, I am substituting x and y value. 3 into 1 is 3, minus 3 equals to 0. So 3 got cancels, 0 equals to 0. It means LHS is equals to RHS. LHS is equals to RHS means this 1 comma 3 satisfies the given equation. Such a ordered pairs we should find. To find such a ordered pairs, what I'll do, my dear students, I'll keep on substitute the values of x. Here it is. So clear. So for the now I substitute the x value as 2, my dear students. So next substitute, put x value, here it is 2, in 3x minus y equals to 0. Is it understood why I am substituting here it is in the equation, my dear students? Because to find out the x and y value in this equation, whatever which value satisfies, to find out that I am giving the value x value 1 and x value 2, and you should give the x values from the set A itself. You should not take any elements outside the set A. Both your x and y value must be from the set A itself. Why? Because you are defining the relation on the set A, and we know that any relation is subset of A cross A. For that reason, both elements or whatever in the ordered pairs you will take, those elements must be from the set A. So my dear students, x equals to 2. If you substitute x equals to 2 in this equation, what happens? 3 into 2 minus y equals to 0. 3 2s are 6 minus y equals to 0. And here it is 6 equals to minus y. If I shift that side, means that will become plus y. So again here it is. If you substitute x value 2, your y value is 6. The next order pair you are getting is 2 comma 6. And next, my dear students, put, here it is, put x equals to 3. I will substitute. Put x equals to 3 in this equation, 3x minus y equals to 0. So 3 into 3, x value 3 I am substituting, here it is, minus y is equals to 0. 3 3s are 9 minus y equals to 0. 9 is equals to y, minus y. If you shift that side, means that will become plus y. So again here it is, my dear students, this point is 3 comma 9 is the ordered pair. And now, my dear students, next I will substitute, here it is, the next one is put x equals to 4 in the equation 3x minus y equals to 0. So in this equation, my dear students, what I'll do? I'll substitute x value as 4. So if you substitute x value as 4, 3 into 4 minus y is equals to 0. 4 3s are 12 minus y equals to 0. Minus y, if I shift that side, means 12 is equals to y. What is the ordered pair? 4 comma 12. And next, my dear students, next I'll substitute, put, here it is, put x value as 5. If you substitute x value as 5 in 3x minus y equals to 0, here it is 3 into 5 minus y equals to 0. 3 into 5 is 15 minus y equals to 0. And now, my dear students, minus y, if I shift that side, means it is plus y. 15 is your y value. My dear students, please observe, here it is what I told till from this starting question, my dear students. We both the x and y value must be in the set A. Whether 15 is there in the set A, 15 is not there, so therefore we should not take this value. I am not taking this value. I can't take the value, here it is, as x value 5, because if you take x value 5, your y value is 15. It means it is not in our set A. So therefore the only ordered pairs which satisfies this relation means that is 1 comma 3, 2 comma 6, 3 comma 9, 4 comma 12. These are the only ordered pairs which satisfies this given relation, my dear students. So therefore what I'll do, my dear students, in the relation R, here it is, what are the elements? So by seeing all this, in the relation R, we have the elements, here it is. So what are the elements we have? So therefore here it is, therefore R is equals to, so R is equals to, what are the order pair? Here it is 1 comma 3, and next, my dear students, 2 comma 6, and next, my dear students, here it is 3 comma 9. So these are the only ordered pairs which satisfies the given equation 3, 9 and 4, 12. So this is your relation R, my dear students. So what are the elements in the relation R? 1, 3, 2, 6, 3, 9, 4, 12. So these are the only elements which contains this in this relation R, my dear students. Clear? So this is here it is here in this in the examination. No need to calculate this one. You can calculate in your own, in your mind you can calculate, or in your rough work you can calculate. So not necessary to write in your annual examinations. I wrote here to it is first time I am solving. So to understand you clearly, for that reason I wrote, my dear students. Clear? And now, my dear students, so now what is the next question? Whatever up to here, whatever what I did, my dear students, just I observed the values of R. It means what are the elements are there in the relation R, that I calculated here, my dear students. And actually my job now it starts. What is that? Whether the relation R is reflexive, symmetric, transitive, that we should check, my dear students. So first one I'll check, my dear students. So what is the first condition? Here it is. First one is here it is reflexive. Let us check whether it is reflexive. So my dear students, reflexive means what I told to you, every element of A must be related to itself. It means in the relation R, what should be in the elements, what could be the values of R? There 1, 1 must be there, 2, 2 must be there, 3, 3 must be there, 4, 4 must be there. If such type of elements are there, means such a relation R we can call it as reflexive. But in the relation R there is no any ordered pairs such type. 1, 1 starting element only not there, 1, 1. So therefore here it is, since here it is, what I'll do, my dear students, since here it is, since the ordered pair, since 1, 1 does not belongs to R, 1, 1 is not contained in the set in the relation R. So therefore since 1, 1 does not belongs to in the R, therefore R is, the relation R is not reflexive, my dear students. So it is not reflexive. Why it is not reflexive? Because here it is no any element of A is does not related to itself. So therefore it is not a reflexive. Now next, my dear students, second one. What is second one, my dear students? Second case is here it is symmetric. Symmetric means what I told. Symmetric means, my dear students, if any ordered pair is there, means the reverse of that, if you interchange the ordered pair or elements of the ordered pair, whether that is contained in the relation or not, that we should check. So let us check, my dear students. 1, 3 is there. Since, again I'll give the reasons. Since 1, 3 belongs to R, 1, 3 is there in the relation R. And now what I told, the reverse of this, it means, but here it is, if you interchange the places, it means 3, 1. Whether 3, 1 is there in the relation R? Yes, here it is no, 3, 1 is not there, but 3, 1 does not belongs to R. Therefore R is, it is not a symmetric also. Therefore R is not symmetric. Next, my dear students, the third condition, what is that? Whether it is transitive. Yes, let's check whether it is transitive. Yes, take the elements. If A, B and B, C, it means here it is, my dear students, here it is 1, 3 is there and 3, 9 is there. Since 1, 3 belongs to R and 3, 9 belongs to R. If the A, B and B, C there, means we should check whether A, C is there or not. Here, my dear students, 1, 3 is there, 3, 9 is there. Then we should check whether 1, 9 is there or not. We should check whether 1, 9 is there, my dear students. 1, 9 is also not in the relation R. Here it is. Since 1, 3 is there, 3, 9 is there, but here it is 1, 9 does not belongs to R. This symbol represents that does not belongs to. 1, 9 does not belongs to in the relation R. Therefore R is not transitive. It is not a transitive. So therefore, my dear students, like this you should solve the question. So this question is a weightage for the 3 mark, 1 mark for the reflexive, 1 mark for the transitive, and 1 mark for the symmetric. Clear? So like this you should solve, my dear students. Still, if you have any doubts, you can comment me. I reply for that. Very simple but very important also. In your annual examinations for 3 marks, such type of questions they'll ask, my dear students. Very important it is. So it is easy to you only if you know the meaning of reflexive, transitive. That all you should require, my dear students. Clear? I hope you understood. Still, if you have any doubts, you can comment me. I'll reply for that, my dear students. Am I clear? So next we'll move to the next question, my dear students, that I'll write. Please pause the video to note it down. The next question, my dear students, that I wrote on the board. So what is that? Here it is. Determine whether the relation R in the set A. So what are the elements of the set A? 1, 2, 3, 4, 5, 6. These are the elements of the set A. Defined as the relation they are defined as, it is collection of all ordered pairs such that Y is divisible by X. So such a ordered pairs we should take, my dear students. So what is that? Y is a divisible by X. Please keep in your mind. Here it is. Y is divisible by X. That such ordered pairs we should take. And whatever you will take the elements of R, that must be from the set of A cross A, because R is a relation defining on the set A. We know that. What is relation? Relation R is subset of A cross A. So my dear students, first what I'll do, I'll write on the A cross A, my dear students. First what I'll do, I'll write A cross A. So what is A cross A then? A cross A means, what is the set A? 1, 2, 3, 4, 5, 6. This is your A cross A. Again A itself. We are defining, here it is. This is the relation, here it is. There is no matter of A and B. There is no such sets they given to you. They given only one set A. Then we should consider that the relation we should take, here it is, elements of the relation we should take from the A cross A. So this is A. Again we are cross, where it is Cartesian product of A cross A we are taking. Again here it is these elements 1, 2, 3, 4, 5, 6. First I'll write, my dear students, A cross A. This how to write this already that we discussed, Cartesian product. So how to, here it is, write means 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. A cross A means what it indicates, my dear students? It is Cartesian product from the set A to A. It means here it is, we should take the elements from the A. Here it is, all possible ordered pairs from the set A and A to A. So such ordered pairs we should take. So here it is 1, 1, my dear students. I'll take 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So with 1 I am taking all these elements. And next similarly I'll take 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Next, my dear students, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. And next, my dear students, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. And next here it is 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And last one is 6, 1. And next, my dear students, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So these are the only ordered pairs. So it means A cross A. So my dear students, we have A cross A. So how many elements we have A cross A? Please observe, here it is. In the A cross A, we have, my dear students, here it is 1, here it is. So 1, 2, 3, 4, 5, 6. 6 means 6 into 6. 6 the 36 elements must be there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, T 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Because we know that here it is n of A, here it is, and n of here it is. If we have the two sets A and B, so in A cross B, how many elements are there? In A cross B, here it is n of A into n of B. So in CET sometimes they may ask. So in the n of A means what, my dear students? N of A means the elements present in the set A, the number of elements present in the set B. So here it is, if you wanted to find the elements in the A cross B means where n of A cross B is nothing but n of A into n of B. So n of A, in this case n of A, both are here it is A itself. So here 6 and here 6. So 6 is the 36. So in A cross A, how many elements are there? 36 elements are there. Am I clear? So my dear students, usually this is not necessary to write, but here it is to understand you concept clearly. So therefore I wrote all this, my dear students. So next, what should we find out, my dear students? The ordered pairs, such ordered pair which here it is, we should find out the ordered pairs which is where y is divisible by x, y is divisible by x. Such a ordered pairs we should calculate. So before calculating the relation, whatever ordered pairs will be there, before calculating that, first I'll tell you what is meant by y is divisible by x. So my dear students, please remember, we have already learned, but still we may have confusions. So A divides B. What is the meaning? A divides B means, my dear students, A divides B means this implies that B can be written as A into some constant. Here it is, A divides B means B should be able to write in the form of A into K, where K is integer, my dear students. It is any integer you can take. You should write the B value as some integer multiple of this A. If you are able to write like this, then we can call it as A divides B. Am I clear? And for example, my dear students, here it is 2 divides 4. 2 divides 4 means what it indicates? It indicates that this 4 can be written as 2 into some integer, some constant K value. 2 I am taking. So here it is, can I write 4? 2 2s are 4. Both are equal. So here it is, 2 divides 4 means 4 must be right in the form of 2 into some multiple to this element, some multiple constant integer we should able to multiply. Such a number, such type, if we are writing means, then we can say that 2 divides 4. The same way, my dear students, 4 is divisible by 2 also we can call. So 4 is divisible by 2 means what it is, my dear students? 4 must be possible to write in the form of 2 into some constant. So therefore, my dear students, A divides B means B can be written in the form of A into K. If it is possible to write in this form, then only we can call A divides B. And also we can call here it is B is divisible by A. Clear? If you are able to write in this form, then only we can say A divides B, or B is divisible by A. So this concept is very, very important, my dear students. If you know this properly, then only we can solve this question. So therefore I told this, my dear students. So whenever you have this concept, A divides B means what? B can be able to write in the form of A into K. A into K, please remember, K must be, it is integer. Clear? So therefore like this we can solve, my dear students. We can take the concept of this. So now, my dear students, with this, so let's move to the question. So what is that? We should write the, here it is, we should take the relation R. So how will be the relation R? Here it is. Let us take the R elements. Here it is. So R is, here it is. So what are the elements? Here it is R. Here it is. It is a collection of all ordered pairs such that Y is divisible by X. So such a ordered pairs we should take, and that ordered pairs must be from the set A cross A only, because we know that the definition itself tells that R is a subset of A cross A, for that reason. And now, my dear students, please remember, here it is, 1 is divisible by every number. Here it is 1 comma 1. You can take 1 comma 1. Here it is 1 comma 1 I can take, because here it is 1 divides 1, because 1 can be written as, here it is 1 is equals to 1 into 1 I can write. So every number 1 is divisible by, here it is every number is divisible by 1. If you take 6, my dear students, so 6 is here it is, sorry, 1 divides 6. It means 6 is divisible by 1, because 6 can be written 1 into 6. Clear? So therefore, my dear students, every number is divisible by 1. So therefore, we should take all the ordered pairs such type of, here it is 1 comma 1 I will write, here it is 1 comma 1, because 1 is divisible by 1. If you take 2, whether 2 is 2, here it is 2 is divisible by 1. We are taking in this form, my dear students, y is divisible by 1, 2 is divisible by 1. I will take this one. Here it is 2 is divisible by 1, 3 is divisible by 1, so 3 1 comma 3, 4 is divisible by 1, 1 comma 4, and next 1 comma 5, 5 is divisible by 1, 6 is divisible by 1, 6 is, here it is 1 comma 6, 6 is divisible by 1. Why it is so, my dear students? Because here it is, why I am writing all this means, here it is 1, here it is 1 divides 5, because 5 can be written as 1 into 5. It means 5 is, here it is 5 is divisible by 1. Every number is divisible by 1, my dear students. So therefore I am writing all these ordered pairs. I am writing, here it is. Next, here it is 2 comma 1. Whether 1 is divisible by 2, my dear students? Yes, please check. Here it is 1 is not divisible by 2. Here it is 1, sorry, 2 is divisible by 1, but 1 is not divisible by 2, but 2 is divisible by 2. So here it is 2 is divisible by 2, 3 is not divisible by 2, 4 is divisible by 2 comma 4, 4 is divisible by 2, 5 is not divisible by 2, 6 is divisible by 2, here it is 2 comma 6. And next, my dear students, 1 is not divisible by 3. Am I clear? But 3 is divisible by 1, but 1 is not divisible by 3, 2 is not divisible by 3, 3 comma 3, 3 is, every number is divisible by itself. So therefore 3 comma 3, 3 is divisible by 3, 4 is not divisible by 3, we should not take this order pair in that relation, 5 is not divisible by 3, 6 is divisible by 3, so therefore 3 comma 6. And next, my dear students, 1 is not divisible by 4, 2 is not divisible by 4, here it is 2 is not divisible by 4, because 2, here it is 4 divides, is 4 divides 2? No, because we cannot write 2 in the form of 4 into some value. We can write half, but half is not an integer, we cannot write. So therefore this implies that 2 is not divisible by, here it is not divisible by 4. 2 is not divisible by 4, we should not take. 3 is not divisible by 4, but 4 is divisible by 4, because every number is divisible by itself. 5 is not divisible by 4, 6 is not divisible by, 6 is, am I right? 6 is also not divisible by 4, because, my dear students, 6 I can't write in the form 4 into some value, it is also not divisible. 1 is not divisible by 5, 2 is not divisible by 5, 3 is not divisible by 5, 4 is not divisible by 5, and 5 comma 5 is divisible by 5. I can write 5 comma 5, my dear students. And next, 6 is not divisible by 5, 1 is not divisible by 6, 2 is not divisible by, 2 is divisible by 6, my dear students. So therefore I can write, here it is, here no, 2 is also not divisible by 6, because 2 I cannot write 6 into some value. Clear? And 3 is, but here it is 3 is also not divisible by 6, 3 is also not divisible by 6, 4 is not divisible by 6, 5 comma 5 is not divisible by 6, 6 comma 6 is divisible by 6. So therefore, my dear students, these are the only elements of the relation R which satisfies the given condition, my dear students. Am I clear? So with this, next what I'll do, my dear students, these are the just elements of the relation R. These are the just elements of the relation R. And next we should check, my dear students, whether this relation is, whether it is a reflexive or symmetric or transitive, that we should check, my dear students. Clear? So next we'll take my dear students. So just I'll take whether I'll just recall my dear students whether the elements are right or not. So just cross I'll check. So 1 comma 1 is there, 2 comma 2 is there, 3 comma 3 is there, 4 comma 4 is there, 5 comma 5 is there, 6 comma 6 is there. So 1 comma 2 is there, 1 comma 3 is there, 1 comma 4 is there, 1 comma 5, 1 comma 6 is there, and next 2 comma 4 is there, 2 comma 6 is there, 3 comma 6 is there. So totally my dear students 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So there should be my dear students 14 elements must be there. Whether 14 elements are there or not, let's check. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So these are the only elements which satisfies the given relation R. And now my dear students, what should we check? Whether it is reflexive or not. To say the reflexive, what I told to you, any relation R is said to be reflexive if every element of A is related to itself. It means 1 comma 1 must be there, 2 comma 2 must be there, 3 comma 3 must be there, 4 comma 4 must be there, 5 comma 5 must be there, 6 comma 6 must be there. Whether all these elements are there or not, let's check my dear students. 1 comma 1 is there, 2 comma 2 is there, 3 comma 3 is there, 4 comma 4 is there, 5 comma 5 is there, 6 comma 6 is there. So therefore the relation R is reflexive. Clearly you can say my dear students. What is that? Here it is. Clearly I can say here it is. The first condition I am going to write. Clearly R is reflexive. R is reflexive because R is reflexive because my dear students, A comma A belongs to R. For every A belongs to A. From the every element of the given set A, every element is related to itself. So therefore R is reflexive. Then what about second one, symmetric, my dear students? If you take 1 comma 1, so if you interchange means the interchange the places means 1 comma 1 is also there, 2 comma 2 is there, 2 comma 4 is there. But my dear students, 1 comma 2, the reverse of this is 2 comma 1. Whether 2 comma 1 is there in the relation R? Yes, 1 comma 2 is there. Here it is. Since here it is 1 comma 2 belongs to R, but 2 comma 1 is there. Here find search. Let's search my dear friends. Here it is 2 comma 1 is not there, but 2 comma 1 does not belongs to R. It is not contained in the relation R. Therefore R is not symmetric. It is not symmetric, my dear students. Am I clear? And next, my dear students, the third condition is whether it is a transitive. Let's check, my dear students. Yes, whether it is a transitive or not, please check here, my dear students. Let us take the every element is here it is. If A comma B is there, well, let's check, my dear students, whether it is transitive or not. Please check here it is. It is no, it is transitive, my dear students. It is transitive. Why it is transitive? You can check. If you take 1 comma 1, 1 comma 2 and 1 comma 2, 1 comma here it is. 1 comma 1 is there, 1 comma 2 is there. It means 1 comma 2 whether it is there or not, check. So 1 comma 2 is it's here. So like this every element is there. So therefore you can check, my dear students, every ordered pair you can check. 1 comma 3 is there and next 3 comma 3. It means 1 comma 3 whether it is there. Yes, it's here. 1 comma 3 is there. Like this every element is there. So therefore my dear students, since if here it is A comma B belongs to R and B comma C belongs to R, this implies that A comma C belongs to R. Since here it is A comma B belongs to R and B comma C belongs to R, and this implying that A comma C also there in the relation R. So therefore it is, therefore R is transitive. So therefore R is transitive. So therefore my dear students, what is the question given to you? Is symmetric, reflexive and transitive. They asked you to check. So therefore my dear students, what is my answer? The given relation R is reflexive. It is reflexive but not symmetric and also transitive. So therefore here it is. What is my conclusion, my dear students? So therefore R, the given relation R is reflexive. Here it is reflexive and transitive. Reflexive and transitive but not symmetric. But it is not a symmetric. So this is your answer, my dear students. Like this you should solve the questions, my dear students. We'll continue in the next video. Still, if you have any doubts, you can comment me. I'll reply for that, my dear students. Thank you. Please pause the video to note it down.